They'll be fine. All right. If we look at this, so we have our x and y. The question says, what is the angle? So how can I find the angle? Like, or my bad. Oop. How can I find the angle? Yeah.
Inverse tangent.
Inverse tangent. So you're gonna have the inverse tangent of the 1.7 or 1.8. Inverse tangent of 1.8 over 1.96. What angle do you guys get?
42.46.
42.46. So 42 degree.
Yeah.
Does that kind of make sense? How we do that? Yeah.
So we found the angle in the bottom right, correct?
Correct.
Then, so is that equal to the one in the top left?
Correct.
Okay, did not know
Okay. Now, that was the first question. Then it said, what is the tension? So what is the hypotenuse? How can I solve for the hypotenuse? Pythagorean theorem. So a squared plus b squared equals c squared. So I'm going to have 1.8 squared plus 1.96 squared is equal to c squared. And I got my answer to be 2.64. Or actually, I rounded a little bit. Might be a little off. 1.8 squared. Squared. I got 2.66.
that. When did B2 sig big? Since it's 1.8.
But you're adding.
Oh,
So when you're adding, there's two numbers past the decimal point for that. There's 4 numbers past the decimal point for the first one.
okay. If it's adding, wouldn't it be the fewest decimal places?
Correct. So 2 after the decimal.
Because it's 1.8 squared, it's not just.
Okay, yeah, I get it.
All right. So that would be newtons. Does that kind of make sense? That's probably one of the most detailed questions you guys are going to have.
Okay, I can live with that.
Okay. Let's see. Now, we'll go over one more. And then I do want to get to universal. So let's look at, we're going to look at a banked curve real quick. So we're actually going to go to, have you guys ever seen Grease?
So like get up sand?
No, the movie Grease.
Oh.
Yeah.
It's a old
on. Yeah.
They're driving, when the dude's driving on the banked curve, they're racing.
Oh yeah.
Pretty good. It might be Grease 2 in that movie. I forget what Grease it was.
No, it's the first
It's
one.
the first.
Is that just with more sodium?
Is that what Grace like you?
So it's the same concept. However, force normal this time. We're looking at force normal at an angle. Okay. So we're going to look at banked curve. So the definition part is on the top. This isn't a problem. We're not solving a problem right now.
Where's this definition?
It is not an.
Well, that's just an outrage.
We didn't have them last time either.
Yeah. What?
You didn't have this problem? Or
Well, no, we had that one, but like
Yeah, but we didn't
the
have a-
equation, we didn't have a place to put that or anything.
I just took mine from yours. So how does mine have it?
Yeah, sounds nice.
Well, that's just wild. All right, so I need one of your papers. I don't know why mine's different. All right, here we go. So there's not a new equation, but we're going to go over, let's see, what's the next one? Oh yeah, I forgot my video. Oh.
Maybe it's when you record something with the line.
I know, but other times it has allowed me. I am recording. I don't know. That's a
Because
great
I remember
question.
only working on like the virtual days and you didn't record them.
At least
You were
it
at your
worked
house.
when we needed it to.
Google Day
So if we look at this, doesn't that way? Have you guys seen
I watch it for Justin.
what's that movie? There's a movie,
The Wall of Death.
the Mel Gibson movie.
You get over Charleston, that's hilarious.
Great movie. It's not one of his more known ones. Daddy's Home is hilarious.
He's in the Shady Killer.
Mad Max. Have you guys seen the Mad Max?
No.
With him in there, the Thunderdome.
Oh yeah, they're just like
Yeah, they ride around the thunder. Yeah.
The
Pretty cool.
Patriot and Braveheart are such good movies. Sorry, I know that's
We
not-
directed Hacksaw Ridge too.
Daddy's Home 2 is pretty funny too.
Hacksaw Ridge is fantastic. It is.
Is that the one?
Andrew Garfield.
He's a
I like
medic.
Toy Story.
Yeah, he's a medic and he doesn't fire.
Yeah.
The original.
That's good.
I cry every time.
All right,
I'm not
So,
afraid to admit that.
we're gonna try one of these. We're gonna try one of these, and we're gonna get to universal. All right, so problem 15: a 500-kilogram car rounds a corner of a radius of 65 meters and is banked at 30 degrees. What speed should the car have in order to make the turn with no assistance from friction? Okay. So if we look at this, what force is holding me going in a circle? What force allows me to go in a circle? Centripetal force, right? So if I'm looking and zoom in, my force,
Can't see.
oh. There we go. My force normal, okay? So what speed should it allow me to move in a circle? So what I'm gonna do, I'm gonna draw a little picture for you guys first. All right, so I'm going on a banked curve, okay? Looks something like that. Got my car. It's gonna be a box car. All right, let's see. What all do I know? Well, I know the force of gravity is going straight down, correct?
Yes.
And that gives me the force normal in the y direction. All right, it doesn't give me the force normal, it gives me force normal in the y direction. So that will give me mass times acceleration. So the mass is 500 times 9.8. I got force normal to be 4,900 in the y.
Yep.
Okay. So we know that. Okay. I gotta find force normal in the x to find the overall force normal. Okay. Now my force normal x, I wrote that really small. I'm sorry. Let me see. My force normal in the x is my centripetal force. Okay, that's my centripetal force keeping me in a circle. So my centripetal force equation is mass velocity squared over r. Does that kind of make sense?
Wait, so the force normal on the x equals the.
Oh, yep, my bad.
Okay.
Yes, you are correct. Force normal. Okay. Now from that, let's see, what all do I know? Okay, so I know my mass. My mass is 500. Okay. It says, what speed am I going at? Okay, so I'm solving for v squared. My radius
65.
is 65. So I have to find my force normal in the x direction to solve this problem. Now, in my problem, I'm told what angle I have, correct?
Yes.
That's probably what I was missing up here. So I'm missing my angle, which is 30 degrees. So I was missing 30 degrees up there. Can you guys see that? Okay. Because on my paper, I'm writing really small, and I'm sorry about it. So 30 degrees. Now, can I solve force normal x knowing the angle and the y?
Couldn't you find just force normal using?
Like, I used the notes, because I thought that, like, if it's a vertical, I thought that wasn't just force normal, I thought that was force normal times the cosine of theta. So it'd be force normal, so 4,098 times the sine of 30, sorry, cosine of 30.
So cosine. That would give us the force normal. We're trying to find force normal in the x right now. Because force normal in the x was equal to our centripetal force.
Okay, that makes sense.
So force normal in the x, I'm going to use tangent. So tangent of 30 is equal to opposite over adjacent. Opposite over adjacent, so force normal x. What do you get for force normal x?
Wait. Wouldn't it be adjacent over? If that's 30 degrees right there, the adjacent would be the y.
400 over at the bottom.
Did I mix that up?
Yep.
I did flip that. My bad.
Because you wrote the force normal with the y at the top, so it's probably your left.
Sokatoa. Toa. Oh, I got you. 49. That's my bad. My bad. It's Friday. All right. That was my bad. Tangent of 30 times 4,900. All right. I got 2829. Is that what you guys got?
Yep.
Force normal in the x is 2829. So my force normal in the x, that's equal to the centripetal force, I can put 2829 right there. And that should help me solve for velocity. Does that kind of make sense? Yeah.
I'm so confused how you can use for force of gravity for the normal force in the y direction. Because isn't it on a slope, so shouldn't that, like, change?
The force normal, so I'm not solving for force normal. The force normal in the y would, like, if I'm on a flat surface, if I'm on a flat surface, my force of gravity is going to be equal to my force normal. But in this case, since I'm on a curve, my force of gravity will not equal my force normal. It will equal the force normal in the y. Because then there's going to be a force normal in the x, and that will equal my overall force normal.
Okay.
Does that kind of help out? Okay, what did you guys get for velocity?
19.177.
2.177. So 1 sig fig because of the 500. So 20?
I didn't know how to say things.
Does that kind of make sense? So if we look at B, if the car went slower, what would happen? Car went slower, what would happen? The lady kind of said it in the video.
It wouldn't hold up against the boundary.
Gravity would.
It would fall, right? Yeah, it wouldn't hold up on the slope and it would fall towards down the incline. And if you went faster than this, you'd shoot off, right? You'd go up the hill. You'd go in the incline. Does that kind of make sense?
Yeah.
Yeah.
Are we going to be doing any questions for the cars that are taking the fastest route around one?
Oh, no. Be intriguing though. If you look at like NASCAR and their routes they do, definitely be intriguing to research that. All right, we're gonna be talking about universal gravitation. We're getting into my planets. All right.
That's a cool, is that Earth?
This? Yep.
Why is it so big?
Why is the moon so big?
Yeah.
Is this from you?
We need just one.
All right. All right.
And then we get like.
So,
Yeah.
if we look at this, so before you get to number 18, well, I guess we skip 22. Before you get to concept question 4, I want you guys to write down this equation. This is a key equation that we're going to be using every single problem from now on out. Pretty sure every single problem.
Is it on our formula sheet?
I don't believe so.
It's on the bottom of the second column. It's like third up from the bottom.
Oh, yep, it is on here. It is. It is on your equation.
Sick.
Okay. So why do we use this equation when calculating gravity, when we know gravity is equal to mass times acceleration due to gravity? Why do we use this equation?
Because gravity can change.
Gravity can change, right? Wherever we are, all right? Gravity can change when we're on the moon, it can change on Mars, but whenever we use that equation, we will always get the correct answer, okay? So the force of gravity is equal to G, the constant of G. All right, I would write that down. And then mass of one object, mass of two. I always just do M1, M2, honestly. I think your equation sheet did M1, M2. Yeah.
Does the big M have to be like the bigger metals, or does it really matter?
Doesn't matter. Okay. All right, we're gonna try one problem out, and then we're gonna do the little riddle guy. Sound like a plan? Yeah.
So, random question.
Yeah.
It's got me thinking for planets. Is it true that they changed the way you pronounce Uranus?
It's Uranus.
Yeah, Uranus.
I don't.
I was actually asking, because like, someone said something about that, but I wasn't sure.
I don't know.
What a funny joke going.
You want to know sad news though? Like when I was growing up, Pluto was a planet. It was like one of the coolest things. And then actually, I know they were bouncing back. Is Pluto still not a planet?
Yeah.
It's not a planet. So there's actually I don't know the term I'm looking. A sphere sized shape of Pluto after Pluto. Okay, so there's Pluto, and then there's like a planet-sized Pluto after Pluto. So when I was going through school, they were trying to get that to be a planet. But then they kind of like backtracked and said, well, that's not a planet. So they said Pluto's not a planet. And I was like, we could have had.
Because it was like we were going through school and like, oh yeah, here are the Pluto's a planet, and then like 1 year it's not a planet anymore. We're all like, what?
Yeah.
So sad.
The
I mean,
acronyms
we
all
could
get
have
messed
Pluto
up
part
now.
two.
There's no end.
I know.
Yeah.
I get 9 what? 9
9
pizzas.
We have a flat Earth society. Why can't we have a Pluto as a planet society?
Honestly.
I
Or
don't
is that
know
bad?
what the other spheres are.
All right. So
Yeah.
this is kind of review. You don't need to write this down. Gravity is the attracting force. The more mass, the more attraction. So if your M1 and M2 increase, the more gravity you're going to have, the more force of gravity. And then as you get closer, the gravity also increases. Okay?
So is that why on my 600-pound life that the couple's always 2 fat people because the gravitational pull attracts them together? Is that?
I don't even really want to.
Did you just say that?
I actually know somebody that was on that.
So-
Where did that come from?
If we look at this problem, at which point will the gravity be the strongest? And at which point will gravity be the weakest? What's going to be the strongest?
Hey.
A is going to be the strongest because it's the closest. What's the weakest? D. D is the weakest because it's the farthest. So we're going to try one problem out.
Oh, let's go.
Only one.
Are those like the video?
It was. We'll show it. All right. So here's an example. Determine the force of gravitational attraction between Earth and a 70-kilogram physics student if the student is standing at sea level, which is 6.38 times 10 to the 6 meters from Earth's center. Let's try to solve this out. So, knowing my equation, all right, my equation is, I've got to zoom in a little bit. My equation is force of gravity is equal to big G M1 M2 over R squared. All right, so the force of gravity, the big G is 6.67 times 10 to the negative 11th. You're gonna memorize that number real soon. All right, times mass. So I'm just gonna do the mass of the student because that's 70 times the mass of Mother Earth, 5.98 times 10 to the 24th over the radius. So it says I am this distance from Earth's center. Well, that would be the radius. So that's 6.38 times 10 to the 6th squared.
These are big numbers.
That's a negative 11, by the way. So try plugging this in your calculator. 6.67 times 10 to the negative 11. Okay, so what I got 686. However, one sig fig would be 700. Now, ladies and gents, real quick, one thing I want to point out was, if you're on Earth, could we just have done 9.8 times the person's mass?
No.
On Earth, yeah, we could. What's 9.8 times 70? 686.
Which is 7. Oh!
Whoa.
Man, that's not happening.
So on Earth, we can do that. All
Mind
right.
blown.
So it depends on the altitude. It depends on the altitude. If you're at sea level, that's true.
Mr. Valley?
Yes.
Why is this equation kind of similar to Coulomb's law in chemistry?
Coulomb's law. Why is it similar? I don't know that. I don't know why it's similar. All right.